every single day inside gigantic General Motors manufacturing complexes. Enough steel, aluminum, wiring, glass, and plastic move through the production lines to build entire neighborhoods worth of full-size SUVs before most people even finish breakfast. Deep inside these billion-dollar factories, massive robotic arms weighing more than pickup trucks swing through the air at terrifying speeds, throwing sparks hotter than lava while assembling Chevrolet Tahoe SUVs with millimeter precision. One tiny mistake here can destroy a vehicle worth over $70,000 in seconds. And somewhere near the end of this process, hidden behind heavily guarded inspection zones, one silent machine scans every single Tahoe body for flaws smaller than a human hair. Miss even one defect, and the entire SUV can fail before it ever reaches a dealership. But the truly insane part is not the robots, or the fire, or even the speed. It is the unbelievable secret system General Motors uses to keep thousands of moving parts arriving at the exact right second without shutting the entire factory down. Because if this production line stops for even 1 hour, the company can lose millions of dollars before lunch. The scale of these factories feels almost unreal. Some production facilities stretch across millions of square feet, large enough to fit dozens of football fields under one roof, while conveyor systems constantly move unfinished Tahoes through endless sections of welding, paintings, assembly, testing, and final inspection. Thousands of workers and robots operate together in near-perfect synchronization. Overhead cranes carry giant metal panels through the air like toys, while automated guided vehicles silently deliver components weighing hundreds of pounds directly to assembly stations without human drivers. And despite all this automation, humans still remain critical, because what happens inside these factories is far too complicated for robots alone. The process begins with massive coils of high-strength steel arriving by train and truck in quantities so enormous they can weigh hundreds of tons each. These giant steel rolls are fed into stamping presses powerful enough to shake the floor beneath them. And this is where things start getting violent. Some of these stamping machines generate thousands of tons of pressure in a single strike. In less than a second, flat steel sheets are slammed into precision molds that instantly shape doors, roofs, hoods, side panels, and floor sections for the Tahoe. The noise is deafening. The force is unbelievable. Entire sections of metal are transformed so quickly it almost looks fake in slow motion. But this tiny detail changes everything. Modern Chevrolet Tahoe panels cannot simply be strong. They also need to be lightweight enough to improve fuel efficiency while still protecting passengers during crashes. That means engineers must carefully balance dozens of metal thicknesses across the SUV body. Some sections are designed to crumple during impacts, while others are reinforced to stay rigid. Hidden structural pieces inside the frame absorb enormous crash energy long before passengers ever feel the impact. And every single piece has to fit together with insane precision, because even a tiny alignment issue can create wind noise, water leaks, or dangerous structural weaknesses later. After stamping, the metal parts enter one of the most mesmerizing stages in the factory, the body shop. This is where hundreds of robotic welding arms come alive simultaneously in what looks more like a science fiction battlefield than a car factory. Sparks explode in every direction as robots grab panels, rotate them through the air, and weld thousands of points onto the Tahoe frame with terrifying speed. Some robots can complete welds in just fractions of a second, while moving with accuracy impossible for human workers to match consistently for hours at a time. And yet, despite all this automation, experienced workers constantly monitor the process because one hidden problem can quietly spread through hundreds of SUVs before anyone notices. A slightly misaligned welding tip, a microscopic crack in a panel, a temperature fluctuation inside the metal. Veteran technicians can sometimes detect issues simply by listening to how the robots sound while welding. That human instinct still matters in factories filled with billion-dollar technology. Once the Tahoe body structure is fully welded together, the unfinished shell enters a stage so carefully controlled it almost resembles a laboratory, the paint shop. And surprisingly, this is one of the most expensive parts of the entire factory. Dust particles floating in the air can destroy a perfect paint finish, so the environment must remain unbelievably clean. Workers wear specialized protective clothing, while advanced air filtration systems constantly remove contaminants from the atmosphere. Before painting even begins, the Tahoe body is submerged into massive chemical baths that clean and protect the metal against corrosion for years. Then comes the moment that completely transforms the vehicle visually. Robotic paint sprayers move around the SUV body with elegant precision, applying perfectly even layers of primer, color, and clear coat. Some paint systems can measure spray thickness with astonishing accuracy to avoid wasting material while still producing that deep, glossy finish buyers expect. And the paint ovens are absolutely enormous. Tahoe bodies slowly travel through giant heated chambers, where temperatures rise high enough to permanently cure the coatings into hardened protective layers. But what happens next is unbelievable. After painting, every single Tahoe body enters an inspection zone illuminated with specialized lighting designed to expose flaws invisible under normal conditions. Workers examine reflections on the paint surface, searching for tiny imperfections. A microscopic defect smaller than a grain of dust can force sections of the SUV to be repainted entirely. And remember that mysterious scanning machine mentioned earlier? This is where it appears. Advanced laser inspection systems scan body panels for inconsistencies humans might miss, measuring tiny variations with astonishing sensitivity. One imperfection detected here can send an SUV backward through parts of the process, costing enormous amounts of time and money. Now the factory shifts into full assembly mode, and this is where the scale becomes almost difficult to comprehend. Thousands upon thousands of individual parts must arrive at exactly the right workstation, at exactly the right moment. Seats, dashboards, engines, wiring harnesses, steering systems, suspension components, infotainment screens, windows, carpets, batteries, trim pieces, sensors, and tires all move through an insanely coordinated logistics network that never stops. Some factories operate like giant moving puzzles where every second matters. And if you are enjoying seeing how these giant Chevrolet Tahoe SUVs are actually built behind closed factory walls, take a second to subscribe and like the video. Because what happens next inside final assembly is where the real engineering madness begins. One of the most dramatic moments in the entire process is known as the marriage station. This is where the fully assembled chassis, powertrain, suspension, and drivetrain finally meet the painted Tahoe body for the first time. Massive synchronized lifting systems carefully lower the body onto the rolling frame with astonishing precision. Workers and robots immediately secure mounting points, connect fuel lines, electrical systems, steering components, brake systems, cooling lines, and dozens of hidden connections buried deep inside the SUV structure. And this operation has to happen incredibly fast. Production lines are constantly moving. Delays at one station can create chain reactions affecting the entire facility. Imagine building a massive SUV while it slowly keeps moving forward every second. That is exactly what happens here. Workers train relentlessly to memorize procedures, because some assembly tasks allow only brief windows to complete before the vehicle advances to the next station. Meanwhile, engines arrive separately after undergoing their own intense manufacturing process. Tahoe powertrains contain thousands of moving parts engineered to survive brutal temperatures, vibrations, pressure changes, towing loads, and years of operation. Inside engine plants, robotic systems install pistons, crankshafts, camshafts, cylinder heads, and timing components with astonishing accuracy. Some tolerances inside these engines are measured in tiny fractions of a millimeter, because small imperfections can shorten engine life dramatically. But this is where things get insane. Before a finished Tahoe ever touches public roads, it faces a series of brutal tests designed to expose hidden failures immediately. Water chambers blast the SUV with high-pressure sprays, simulating extreme storms to detect leaks. Computer diagnostic systems check thousands of electronic signals within seconds. Alignment machines measure wheel positioning with laser precision. Brake systems undergo rapid testing, while engines are monitored for unusual vibrations or sounds. Some factories even use rolling dynamometers, allowing SUVs to simulate driving conditions indoors before shipment. And still, human inspectors remain one of the final lines of defense. Experienced workers physically inspect panel gaps, interior finishes, stitching quality, switch operation, lighting systems, and countless tiny details buyers would instantly notice. A crooked badge, a rattling trim panel, a scratch hidden near a door handle. These tiny flaws can cost manufacturers enormous money if customers reject vehicles later. What makes the Chevrolet Tahoe especially fascinating is the sheer complexity hidden beneath its massive exterior. Modern SUVs contain staggering amounts of technology compared to vehicles from just a few decades ago. Cameras, radar systems, touchscreen interfaces, advanced safety systems, adaptive suspension controls, heated seating systems, wireless connectivity modules, and powerful onboard computers all have to function perfectly together. One failed sensor buried deep inside the wiring network can trigger major problems later. And then there is the logistics nightmare behind the scenes. Factories cannot simply store unlimited parts. Many components arrive just hours before installation through highly coordinated supply chains involving countless suppliers across multiple countries. If weather delays shipments, if one supplier fails, or if transportation systems break down, entire production schedules can collapse rapidly. That hidden coordination system teased earlier is what keeps everything alive. Sophisticated tracking software monitors thousands of components moving toward the factory in real time, adjusting deliveries almost minute by minute to prevent costly shutdowns. But perhaps the most shocking reality is the financial scale behind all this. Building and operating one of these SUV factories costs billions of dollars. The robots alone can cost fortunes. Energy consumption is enormous. Paint operations require huge environmental control systems. Conveyor networks stretch for miles. Maintenance crews constantly repair machinery because production never truly slows down. Every minute of downtime becomes painfully expensive. And despite the rise of automation, humans still remain irreplaceable in ways many people never expect. Skilled technicians troubleshoot problems robots cannot understand. Engineers continuously improve efficiency. Inspectors catch imperfections machines overlook. Veteran workers notice strange sounds, unusual vibrations, or subtle production issues before computers even detect them. Inside these giant factories, humans and machines are locked together in a nonstop industrial partnership. By the time a Chevrolet Tahoe finally rolls off the line complete and fully tested, it has traveled through one of the most advanced manufacturing systems on Earth. Thousands of parts from around the world, millions of dollars in machinery, endless streams of data. Heat, sparks, chemicals, lasers, robotics, logistics, and human expertise all combining to create one finished SUV in an astonishingly short amount of time. And that hidden machine scanning for microscopic defects near the end of production? The reason it matters so much is because modern customers expect perfection at highway speeds, in freezing winters, scorching summers, and years of daily use. One flaw invisible to the human eye can eventually create noise, rust, leaks, or system failures costing manufacturers millions in recalls. So before any Tahoe ever reaches a driveway, billion-dollar factories push engineering precision to almost unbelievable extremes, just to make sure that giant SUV feels effortless the moment someone starts the engine and drives away.